a presentation that I originally did several years ago at one of our conferences. It's been updated with a couple of new things and some new insights into other things that were already in there. So I'm going to, let's see, share that again. Okay. All right. Let me know if you, if we can't see anything, if you have any complaints or relevant questions, Rhonda, let me know and we'll address them as we go.
Right now, did you start sharing? Because I don't see your screen right now.
I did. I thought I did. Let's see. Go back. Ah, missed step 3.
There we go. Looks good.
Okay. All right. Better?
Much better. Thank you.
Okay. So this is Tuning Informix, 38 years of lessons learned. So hopefully some of the relevant things I've learned over the years, pass them on. We'll cover 4 basic areas: application performance, database administration, monitoring, and finally performance tuning directly. And the other things are important because you can't tune if you don't know what's going on, right? And tuning your engine, tuning your SQL is only part of the problem. So we're going to look at all of this. Excuse me. So one area that's external to your server that can impact performance are things that are frequently overlooked, right? The 90-10 rule. 90% of your stuff isn't your problem. It's that little 10%. And we'll also look at ways you can kill 2 birds with 1 stone. You fix something and something else gets fixed. Of course, sometimes you fix something and something else gets broke. So of course we're going to look at the SQL, and we're also going to look at the structure of your application, right? Does the application fit the data? Does the data fit the application? All right, and are both monitoring the real reality of the problem you're trying to solve. Okay, so one problem that I deal with in another presentation in a lot of detail, and we're just going to kind of zoom through it here, is that you have to write SQL like a database designer. If you write SQL like a programmer, you're going to be creating SQL that's very inefficient. Okay, because SQL is not a declarative language. It's not a sequential language. It's a language of what is it that I want to get. Okay, so the more you're handling data in your server from your server, the more the SQL has to match the question and not how the application is designed. And we'll get into that in a little more detail. So we want to write the SQL to decouple the application from the schema. So you don't ever want to write select star, because that couples your application to the database schema. If you have to change the schema, add a column, drop a column, change the nature of a column, perhaps change an ID column from an integer to a string, you're going to break your application, right? That SQL is not, it will work, it will continue to return data, but your application may be expecting 6 columns when it gets back 7, or 7 columns when it gets back 6, right? Or expects an integer and it's going to get a string. So you never want to do a select star. You always want to select with a column list that's complete, okay, and only specifies those columns that your application is interested in for the results of that particular query. Similarly, you don't ever want to insert without a column list, because again, if you add a column, that insert that doesn't have a column list is going to break, because insert expects 10 columns, but your values clause only has 9 values in it, right? Whereas if you have a column list with those 9 columns that used to exist in the table, and the 10th new column doesn't exist, as long as you're supplying 9 values to those 9 new columns, and the new column has a default, right, a way of getting populated otherwise, or is not null, then you're good. You're golden. The application still works. New code accesses and populates the new column, and your old code continues to work. Okay. The next question is, does your schema match the data, right, that's being modeled? Are the columns that you have in the table, is the nesting of the tables make sense for the application? Is your database design properly normalized to eliminate redundancies and eliminate problems? And are all the indexes that you need to support your major queries in place? I get called into a client often, and they'll be complaining about something that's running slowly, and we'll discover that 3 new applications have gone into the system since anybody last looked at the database schema, and no one bothered to add indexes to support those new applications and the new schemas. And they were working fine until the database grew a little bit. And now those queries are no longer sufficiently efficient to satisfy service level agreements for the clients. Okay. You know what, let me take one break and turn off my camera because I just noticed I left it on. Sorry about that. So we'll do that. There we go. Okay. Oops. Okay, and we're back. In the SQL itself, here are some suggestions. I'll often see a very large in clause or a long list of or conditions, or a query that has many, many unions. You can't say for sure whether that long in clause or the list of ors or unioning multiple queries to put those or conditions into a query to get the results you're interested in. You can't tell which one of them is going to be more efficient and which one's going to perform best. Same thing with a large in list versus in the results of a select statement versus doing a simple join, or versus doing the in list. Okay. I had a client that had this massive query with a very large in clause, and I said and it was not performing. And the truth was, the bottom line was that it was taking longer to parse the SQL and prepare the statement than it was taking to execute it. And my question was, where did this monster list of keys come from? Right, of filters come from? And they were selecting it out of another table with a select statement and building this monster in clause in their application. And sometimes that's a good idea, but other times maybe you want to just do an in with the select in those parentheses, right? Because that's much quicker to parse and it's going to perform the same. Okay, or maybe it would have been better just to join that other table to the table they were searching. They wanted to search and do a simple join. Okay, and sometimes, as I said, that or can be broken up into unions, and sometimes it can, but you don't want to. And all of this is modified and changed when you can include multi-index scanning, right, in version 12 and later, because multi-index scans will often allow the optimizer to use a separate index for each of an or clause or each part of what would otherwise be a union, and then you can simplify the query, have it parsed more quickly, and perhaps executed more quickly. Other things to look at: what data types are we using, right? And we've got char versus varchar versus lvarchar versus even long lvarchar, which is a fairly new extended type. So fixed character versus varchar. Very often I will see an application that has a varchar 1000 in it, and I'll look at the data, and there isn't a single record that has a value longer than 20 or 30 characters in there. And so we're not wasting any storage, but we are wasting communication bandwidth, because those 20 characters are going to get blown up to 3,000 or 10,000 characters in the result record in order to pass it back to the client. So if we're returning many records with very large LVarchars or varchars even, when the data does not require that large of a value, maybe that's not a good thing. Similarly, rather than a large LVarchar for, let's say, a paragraph of text that a user is entering or that was copied out of another document when the data was loaded, perhaps it would be better if that LVarchar is not always accessed, not needed for every application, to move that column into a child table and maybe break it up into fixed length records with a smaller footprint, and have a sequence of multiple records to contain that text, similar to the way Informix stores the text for a stored procedure or a view. Same thing with lists and sets and multi-sets. Do you really need it for your application, or is it just something cool that you want to use? Similarly for rows and JSON and BSON. Row has its place where you're using the same data structure in multiple tables for similar purposes. It's good to create a row so that you have a consistency, and when you change things from table, as the application changes, you can change that row definition and alter the tables to fit the new row definition, and they'll all be the same again. Right? But again, with row, with JSON, even with blobs and time series, is it the right data type for the application? Goes back to my statement or question about, does the schema fit the application? Does it fit the reality of the data? Okay, and that goes for all of this. Are we using a UDT or an opaque type because it's something cool? Could we do it a different way? Maybe it's the right way to do it. Maybe it's not. Okay. Partitioning. Is the table being partitioned because, well, we just partition tables? Or are we doing it for performance reasons, because, or to isolate the data to increase and improve concurrency? If there's a reason to use a feature, perfect. If there isn't, why are we doing it? Right? Rolling windows are awesome. They're cool. They restrict the ways you can index the table. Okay. Same thing with case sensitivity. Do we want the database to be case insensitive just because our other applications in SQL Server are case insensitive? But that's not the way it needs to be for the application, so why? Okay. Okay. Similarly, serial versus sequence. Should we be using a sequence in here because we're used to using them in other applications, let's say in Oracle, or are we better off using a serial 8 or a big serial or a serial column, which Informix will handle more efficiently? Views and stored procedures. So I see a lot of customers that are hell-bent on making everything a view and not using the real tables, and making everything a stored routine, a stored procedure, putting all of their logic into stored procedure. Both of those things are good when they're used properly, and really awful when they're overused. We want to move business logic into the database, into stored procedures whenever we can and whenever it makes sense, especially for operations that might be shared across multiple applications, so that you have consistency of the code and the way that it works. But if every operation is a stored procedure, then there's a lot of overhead and a lot of contention for sysproc plan and sys procedures. And even sysproc auth, which we know is a known performance issue, which has been improved over the way it was in the past, but still it becomes an issue. Same thing with views. There's good reason to take queries and instantiate them as views. If you were in the previous session, for example, Informix does that with a lot of sysmaster entities, or not really tables, but views over some query across other sysmaster pseudo tables. And again, they have a place to simplify things for the user, for the client, and to make things consistent from one application to another, right? Nobody has to reinvent the wheel over and over again and remember which 3 tables have to get joined to get this data out. But they're easily overused. I had one client that their company rule was never query the base table, always query a view. And very often that view contained select star from table, which to me made no sense at all, but okay. And there's an overhead to doing that. Sharding, setting up ER clusters, using writable secondaries, shared disk secondaries, and Informix Warehouse Accelerator, and I even didn't put on here, but transaction survival. Those are all incredibly powerful and incredibly cool features. But are we using it because we have a need for it, or are we using it because it's something cool, right? Do we need to shard the table across 4 or 5 or 6 servers for actual scalability and performance, or are we doing it just because, right? Have we set up a 2-server ER cluster when we could be using an HDR writable secondary? Or conversely, are we using an HDR writable secondary when the better choice might be a 2-server peer-to-peer ER cluster? We have to make decisions based on actual requirements and needs rather than what makes sense. Same thing goes for Informix Warehouse Accelerator. Do we need the Warehouse Accelerator? Because there's a lot of management overhead to using it. Although it's really cool to get a query that that normally would take 4 hours to process, complete in 7 seconds. That's really, really cool, especially if your SLA is to get it done in 7 seconds. Same thing, time series is a very cool feature, great feature. A lot of data analysis can't be done efficiently without it. But if we're doing queries against that data that are not time series style queries, perhaps the better choice would be to put it into a traditional relational schema. And that will take up more storage space and perhaps use more CPU, but it might return the data a whole lot faster. Okay. Okay, moving on to database administration. What is not database administration? I'm going to tell you that database administration is not about what goes wrong with your server and what to do about it. It's not about taking your archives. It's not about adding space to the server, building and rebuilding indexes, organizing fragmented tables. It's not really about tracking down performance issues, although all of that, including, and creating new indexes when there are performance issues, and updating user privileges and creating stored procedures, all part of the job. But it's not what the administration is about. What it's about, yeah, to me, those are the things you do when you've got time, right? And you make time for them. But what it really is about is making sure that your server is reliable, secure, safe, performant. Yes, that goes back to getting the queries to perform, adding the indexes. Those are how we implement our job. But our job is to make sure the server is there, the data is safe, it's available, it's useful, it's relevant, it's going to perform, right? That's the job. Everything else is detail. Okay. And so you have to concentrate on that. So what is it about? It's not about taking archives. It's about validating your archives and doing test restores to make sure that when you need the archive, that it's going to be there and it's going to be useful. You don't want to find out that this week's archive has been corrupted in 2 days when the server crashes and the disks are trashed, and you have to go do a restore, because then you're going to have to restore from last week's archive and roll forward 2 weeks worth of logical logs. assuming weekly backups, of course, which is not ideal. But as an example, it's about planning the server layout so your storage is efficient, so that hot tables are not sitting in the same place on disk or in the same DB spaces. It's planning and testing your DR strategies, right? Can we crash the engine and recover from it? Can I shift my primary from my main data center to my backup center at the other end of the country because there's a hurricane coming in and I'm concerned that we're going to lose the data center, right? How do I avoid and minimize planned downtime, right? Do I want to use, do I want to make sure that we're using only columns in tables that are likely to change that can be altered with in-place alters, right? Excuse me. If I have to make a change to a major table that's going to require major downtime, might it be more efficient instead to create a sibling table with the new columns in it, rename the original table and replace it with a view temporarily until we have a scheduled downtime to eliminate that downtime when we can't take it. All these kinds of things. Reviewing SQL applications more often than I'd like to see. The DBAs and the data architects are not involved in code review. We ought to be at every code review meeting. And we should be standardizing and contributing to the standard code practices and how to access our databases. Because we know how the server is going to work and how it's going to react to a new query. The application developers do not. And the application developers manager who's doing the code review does not. Okay, not to the same extent that we do, even if they're very experienced. And we want to plan schema changes to support the new functionality so that we can make them in a way that minimizes their impact on the server and on performance. Okay. We also part of this is planning for future projects. If you know, excuse me, if you know that certain projects are coming down the pike, and again, that's part of being involved with the development team early in projects, right? Not just after the fact, and even not just for code review, but as early in the process as possible, so that we can plan on those changes. At Bloomberg, we made application changes twice a week, and often that involved database schema changes. And what we had set up was that all schema changes were designed so that the new application, the old application, could continue to run with the new schema, so that I can move the database schema changes the week before the code moved, and that if we had to roll back the code, that the old application would continue to work with the new schema, and I wouldn't have to roll that schema back in lockstep with the code rollback, so that we can get the system back up and running as quickly as possible. That's part of the job. Planning for growth, right? Not only saying, oh, this DB space is growing by 15%, it's going to run out on the 5th of December, I need to order new disks, right? But also working with the storage guys, because when you tell them on October 10th that we need new disks by December 5th, and they go, well, I could get the disks, but we're going to need a new frame to hold them, and that's going to take more than 2 months. So, right, so we have to plan ahead as much as possible. Plan for organic growth. Organizations grow. Any organism that doesn't grow begins to die. That's a rule of biology, and it works for organizations too. And we also have to plan for evolutionary organizational growth, right? The company is not only just going to grow on its own, but it's going to expand into new markets. It's going to expand into new products. There's also going to be revolutionary change, right? The internet was one of those revolutionary changes for companies. Certainly e-commerce was a revolutionary change for companies. And if they did not do sufficient planning for it, it was very painful for a lot of organizations. We don't want to be in that place ever again. So what else? We want to monitor the server performance and monitor the system's performance. That's part of our job because it's not fixing the performance problems. That's our job. It's discovering the performance problems before they become an issue for our customers and our clients, our users, even our internal users. Learn what the organizational goals are, what the plans for the organization are. Insert yourself into the process. Make sure your managers keep you in the process. Learning about the application and the data environment. Too many DBAs have no idea what the apps do. They only know their database. You have to be part of the process. Notice that's a recurring theme for me. Also, learn everything you can about Informix features. You guys are doing it now. You're here. There were many people on the previous session, which was about new features. That's great. That's what you need to be doing. That's what your colleagues need to be doing. Also learn how to interpret the metrics and monitoring data, right? It's not just enough to collect it and look at it. You've got to understand what it means and how it affects capacity planning for the future. Okay, when are we likely to outgrow our system? Is the CPU utilization rising from 70% to 80% now? Look at that. We're going to start getting a wall soon. Okay. So let's talk about monitoring. What do we monitor? The simple answer is we monitor everything we can get our hands on. Because if you don't have the information, you can't do anything about it. So some of the things that I monitor that I want definitely collect are certain server metrics. Those include buff waits ratio, buffer turnover ratio, and now the new BTR3, which we'll talk about in more detail later. Read cache hit percent, write cache hit percent, obviously. Lock wait ratio. If you're waiting on more than a small, tiny percentage of your lock requests, your server is grinding, and your users are getting in each other's way. You have concurrency problems. Sequential scan rate. What that actually is going to vary by organization based on the kinds of queries you issue, but you have to know what's normal for your organization, for your database, and even from one database server to another to know what's going on. Too many sequential scans and everything is slowing down. Right? Your cache hit rates will go up, etc. We need to keep system metrics, look at CPU utilization, IO saturation, response and service times on your disks. CPU balance. Not only, it's not enough to know that overall we're at 65% of our CPU cycles that are available, but you also have to know that processor core number 3 is running at 98%. And core number 4 is running at 99%, but everything else is running at 42%. Right? You need to know that and find out why that's happening. Perhaps we don't have enough CPU VPs in the server to spread the load across the number of cores we have available. And you also want to monitor peak versus average, looking for trends, looking for when the peaks happen, because do we need to do something about that? All right, do we need to add resources during certain times of the day? You want to also monitor your physical count, physical plant rather, and that includes the number of accents in your data partitions, in your tables, and in your indexes. Are any of your table partitions approaching the maximum page count limit, right? The 16 million roughly pages that a data partition can hold. Do we have to look at moving the table to wider pages or partitioning it? What's my DB space utilization? We've talked about that briefly, right? What DB spaces are getting full, approaching full? Do I have to add more space? Do I have them set up to automatically expand? If I do, are my storage pools filling up? Is the disk behind them filling up? Do I have any indexes that are inefficient? Do I have any indexes that nobody's using? That technology takes up space, but it slows down inserts and updates and deletes. against those tables. Am I wasting storage because the objects are on the wrong page size? Right? If I have an 1100 byte record and a 2K page, I'm only getting one record on a page, and I'm wasting 48% of my storage. Right? Bad idea. Empty varchars and LVarchars we talked about. Sorry, guys, my allergies are making me crazy. You also have to keep an eye on your logical plant, and that has to do with data distributions, aging, the quality of them, the detail level. Let me go back to that and talk about it. So if your distributions are more than n days old, your queries may be becoming inefficient. And you have to know what that aging is for different tables, because if a table is static, you may only need to regenerate distributions for it, I don't know, maybe once a year. Well, that can save some processing time, right? And reduce the overhead on your system. You don't need to be running update statistics on every single table every single day, right? But maybe you have tables that are active and are volatile, but having the statistics up to date within a month is more than sufficient to keep the query plants working properly. So maybe on those tables, you redo your statistics every 20 days to make sure they're always fresh enough. But you don't want them to get past 30 days. Is the quality of the distributions enough for you? Those columns that you do medium distribution, do you have your sampling rate set high enough? Because the defaults don't work well on very large tables. Same thing for the detail level, right? If I have a table, excuse me, if I have a table with 30 billion rows in it, 200 buckets is not going to do the job very often. So you need to know that. You need to know, where you're at, and whether your distributions are working for you or not. Monitor infrastructure, archive retention and retrieval, log backup retention and safety, right? Are my log backups being copied off quickly to someplace safe in case the server hard crashes or the storage does? Right, after every log backup, every log file completes, it should be backed up. Within moments after it's backed up, it should be copied off somewhere safe, so that we can do a restore up to the last moment we can with the backups. Do you have a version history of your on-config file? Because as you make changes to your on-config file, you need to know what was changed when and what it was changed to. Same thing with your schemas. Do you have a version history of your schema? Excuse me. So that if some application suddenly is not doing well, we not only know, okay, was the last schema change, but we have to know what the schema change was and where it came from, and be able to roll back. Instantaneous performance monitoring. Your active threads. You need to know on average, right? How many active threads you have on your system on average, daily, hourly, instantaneous. What's normal, what's not. Same thing with the ready queue. What are your daily, hourly, instantaneous averages? If you normally have 2 or 3 sessions in your ready queue, and suddenly you do an onstat minus GREA, and there are 10 sessions in the ready queue, and they stay there for 5 seconds, there's something going on that you need to track down, right? So the duration of the ready queue is important, and not only knowing what it is, but what it should be, what's normal for your system. So you know what to react to and what to ignore. Session count. I had this at a client 3 years ago. Suddenly their system was grinding to a halt. And the only symptom was that instead of their normal 7,000 to 10,000 session processes, they suddenly had 80,000 sessions in the system. And that was literally the cause of the issue, the performance issues. And something had triggered some bad code to automatically decide that a session wasn't working, and it just launched another copy of itself. And that was happening over and over and over again. So watching the session count was how we discovered why there was a performance problem, because nothing else showed it. How many active SQLs are there? Right? You may have a lot of SQLs defined in your system. Certainly you may have a lot in your cache if you have the cache turned on, the query cache turned on. But how many of them are actually active, and what's normal for your system? Data transfer rates. What's normal data transfer rates for your system? On average, daily, hourly, instantaneously. How fast can I move data from the server to the app server, right? From the database server to the app server. If the app server is complaining about performance and everything looks good on the server, maybe the issue is the network. And you're not going to know that if you can't say, oh, look, I'm not getting the data transfer rate I need. Same thing for I/O requests. You have to know what's normal and average, and for your server on your storage, not just what's good, right? We know that for example, in general, I/O service times more than 15 or 20 milliseconds is dirt slow. But it may be that for your particular application, for your particular database, for your business, you need those times to be under 5 milliseconds. And if they're not, the phone's going to start ringing, right? Cache efficiencies. The SQL cache. I have a client that can't use SQL cache, statement cache, because they have so many new statements going through that the cache just thrashes and slows everything down. So you need to know, is your cache for you working? Is it sufficient? Is it big enough? Is it being thrashed in any way? Okay, same thing for the stored procedure cache, the data dictionary cache, your distribution cache, all of the major and minor caches. SQL trace, right? There are several different ways that you can trap and capture and monitor live queries on your system. I've listed 4 of them here. Obviously, one is SQL trace, Exact Solutions iWatch, SQL Power Tools, and of course AGS Sentinel, and with Server Studio. Any of these ways will let you capture live SQL as it's running through your system to various levels of accuracy, but there are costs to some of that, right? If you make your SQL trace cache too big, it will slow the system down. If you run your trace on high, it may slow the system down, but you may need that data, that level of detail. You have to know what's going on. Okay. So, off to how do we get to tune? How do we tune? First, determine or discover the scope of the problem. What is it I'm trying to solve? And what is it I'm trying to find? And you have to focus on just that. Narrow the search down, identify the issue, right? As we did at that client with the large number of running sessions. We spent a lot of time that day trying to figure out what was going on before we really found the issue and were able to drill down through it. Determine if a single change can improve performance and test it and re-implement and re-examine and retest. Lester is a major proponent of doing only one change at a time. I admit I'm sometimes a little more aggressive, but that is the gold standard. Make one change at a time, test it out, make sure everything is working. You've made some improvement, do it all again. It's an iterative process. Part of determining the scope is who's affected. If only some users are affected, then the problem may not be something in the server, but perhaps something in the application. Is the problem periodic or intermittent? Does it always happen? Does it only happen at 3 in the afternoon? Lester tells a story about a client that was having a problem at 11:30 in the morning and at 4:30 in the afternoon. And it turned out his issue was that people were coming to it was a bank, and people were coming to the bank on their lunch break to cash their checks. And it was causing all kinds of grief in the system. Same thing at the end of the day. Anybody who couldn't go out to lunch was coming in at the end of the day to cash their checks. And it only happened on, I think it only happened on Thursdays or Fridays, whatever day it was. So, is it dependent like that on something that's intermittent, or is it dependent on a time or a date, or a day of the week? When did the problem start? Right? Is it a problem that's ongoing, or did it come and go, and maybe it's going to come back, and we've got to drill down into history? Are we saving history? Right? And when it happened, how long did it happen for? All of that are clues to what the problem really is. Determine the focus. Right? We talked about, is everybody affected? Are all users affected? Only users of a particular application? If it's that particular application, does it affect everybody who uses it, or only certain users? Narrow the search. Look at volumes. Look at structural inefficiencies like that, like indexes that have become inefficient. You can look at the B-tree cleaners and see how they're working. Find out if there's a hotspot on an index that you're working on that affects your problem. That index may be a candidate for a complete rebuild, rather than waiting for the B-tree cleaners to make it more efficient, etc. Narrow the search means reviewing the metrics at all levels. We've already discussed all of these, and going back and starting again. It's all iterative process. Okay, identify the issue. For all of this, you have to concentrate on finding one or two direct causes. And once you find a direct cause, then you can start to figure out how to fix it. Okay. Determine a single change to improve performance. Right, as I said, resist the urge to change everything at once, because one change can cancel the effects of another change. You may put two changes in that independently would each improve performance by 5%, but if you do them both, nothing happens, right? Or performance actually goes down by 5% because they're interfering with each other. That's one major reason to only make one change at a time. If you can, test everything in isolation on a backup server, on a QA server, test under load as much as similar to production as possible. And then once you fix the problem, it may happen again, right? So you have to keep track, at least in some informal way, of what problems came up, how they were fixed. And sometimes you have to take that information and plan for the future. How are we going to keep this from happening again next time we get into this situation? Okay, this is new. Several years ago, I had a client, still have a client, where we could never get the buffer turnover rate to get anywhere near the ideal range. The ideal range for the original buffer turnover rate is less than 10 times an hour. So turning over the equivalent of turning over the entire buffer cache every 6 minutes. If you're turning over your buffer cache more often than every 6 minutes, chances are the cache is inefficient, and you're experiencing serious performance problems. At this client, though, no matter what we did, the BTR was always over 50 for one of their page sizes. So I think it was the 2K cache. It was always over 50, no matter what we did, no matter how big we made the cache. It never changed. And that's when I discovered that there was a problem with the calculation for the BTR, is that it can be skewed on a server that does a lot of inserts. If you have tables that are heavy insert, heavier than query, the BTR will be high. The traditional BTR calculation will be high. So over time, I worked out this calculation, which I call BTR3 or advanced BTR. Okay, it calculates things down at the table level, going through the buffer pool to determine the caching and the turnover of the buffer pool. So on systems that are not insert heavy, the original BTR calculation and this calculation will return the exact same number. On a server that is insert heavy, the BTR3 will return something very close to what's actually going on, whereas the BTR may be extremely elevated, and they will be very different. Okay, so for example, in the ratios.shr_ak in the new ratios script, it still calculates both the BTR and the BTR3. But basically, you can ignore the BTR because it will always be the same as the BTR3 if the BTR was accurate, and the BTR3 will be more accurate when they're not the same. So you can pretty much ignore the BTR and just look at the BTR3 value. This is the calculation for anybody who wants to write their own script. It's just a couple of queries. Okay. And this is the calculation for each buffer pool by page size. Okay, the query is a little bit simpler for the overall BTR3, which isn't always useful if you have multiple page sizes. But if all of your buffers are 2K or 4K, then this will work fine. If you have multiple page sizes, then you want to look at the BTR3 separately by each page size using this calculation. And that's where I'm at.
Thanks, Art.
You're welcome. We have any questions? I see stuff in the chat.
Yeah, there's only a couple things in the chat. Somebody wanted examples of multi-indexing, index scanning.
So sure, an example of where multi-index scan comes in, you have a query that says, for example, where column one equals 4, all right, or column 2 equals 6. Well, if you have an index on column 1, okay, and another index on column 2, without multi-index scan, the engine can only use an index on column 1 or the index on column 2. And it has to do a table, basically has to do fetch the data rows for all the records that satisfy whichever index it looked up, and discard the records that don't match the other filter. With multi-index scans turned on and enabled, the engine will use both indexes. It will use the index to find all the records that match column 1 value filter and all the records that match the column 2 filter. It will sort those row IDs and beat the two lists against each other to create the OR condition, and then just find all the matching records that satisfy both conditions. Okay. Same thing when you're mixing ends and ORs. Similarly. So that's when multi-index scanning comes into effect. And it's just a matter of enabling it in the engine or putting in the optimizer hint that enables it. Do not use Boolean. Yeah, Paul Watson is a strong proponent of not using Booleans. They are slow. They are inefficient. An integer with a 1 or 0 is far faster than Booleans, but they're there. What else can I tell you? I don't see any other questions.
That's all I see.
All right.
So if there's no more questions, well, thanks, Art, for giving us your insight over 38 years.
You're welcome, guys. Everybody enjoy the rest of the conference. Enjoy.
All right, I'm going to stop the recording now. Thank you.
Bye.